It's not the end of the world. Okay, so you have, if it's ionic, and we talked about some of the characteristics and properties yesterday. Ionic compounds start with a metal, always. Always, always, always. To start with something that's on the left-hand side of the periodic table. Hydrogen is not a metal. Hydrogen is a non-metal. Hydrogen is a cation. The second thing you're going to see is going to be a non-metal. Now, there is an exception, and those are polyatomic ions. We're not ready for those yet. We'll do those after Thanksgiving break. We're not doing those yet. Right now, we have what are called binary compounds. Bi meaning two. Two elements. Sodium, chlorine, two different elements. The first thing with ionic will be a metal. It's going to lose its electrons to be positive. Non-metal is going to gain electrons to become however many it gains negative. And what we have to figure out is just how many of the positives are needed for the negatives. Well, if it's a 1-to-1 ratio like this, you only need one of each. Yeah, so I want to show you how to build ionic compounds properly, but it's after Thanksgiving. I just don't want to confuse you. I know how to make it so much easier, but we're not supposed to do that for it yet. Like, okay, so you know those charges we put on the top? Do those add up to 0? So you only have one of each. Do those add up to 0? So you only need one of each. Do these add up to 0? So you need 2 of these for every one of those. We just don't write ones. They literally, like, that's how you build a compound in ionics. Because I'm not supposed to jump that far into it. I can show you algebraically how to do it, and your brains are going to hurt. Or you can crisscross, which is, I'm jumping ahead into after Thanksgiving. So what we're trying to do is essentially go down to 0, okay? Or we're trying to go up to, in most cases, 8. Helium is an exception. It wants 2. And then we're going to go from this to this. Just depends on how many you need. You're going to draw an arrow showing where your electrons are going to. They go from the metal to the non-metal. The non-metals are the thieves. 4 metals are getting bullied and picked on. And then once you figure out where everything's going to go, you just redraw it. Charges go on the top right-hand corner. Yes, I write the number 1. Not every teacher does. And the way that this district wants you to do it is it wants you to show the ones that are around the sodium 2 from the inside shell. I don't do that. I think that would confuse you. I don't want you to think that sodium gained a whole bunch of electrons. It didn't. It actually lost them. I can't remember if I put one more bullet on here. There's my cheat slip. No. I don't do a full octet on the metal. I do full octets only on the non-metals. That is the way I was taught. Okay, so this is on your thing. Let me show you, and I'm so sorry because I really thought I fixed my sparking, and those of you that are online cannot see what I'm doing. And even if I activated my camera and I showed the board, everything would be a mirror image. So I think that would confuse them. Aluminum is in group 3. What is its 3? Or what is its charge? What is its charge? Okay, it's going to end up being positive 3 because it has 3 valence electrons. This is aluminum. I know that's its charge from the periodic table. I'm sort of cheating and showing you stuff from the future. Chlorine, how many dots does it get? 1, 2, 3, 4, 5, 6, 7. What is chlorine's charge on the top of the periodic table? No. Minus 1. What? It's in group 7. Everything in group 7 is going to end up being a negative 1 charge, right? So even though it shows you over there, how many negatives do I need for each positive? 2. So I'm going to need 3 chlorines. I'm putting the lone electron where I know it's going to go. I'm sorry, I know how to do these, so I know the shortcut. Where are aluminum's electrons going to go? Yep, one to each chlorine. I really should have drawn that dot down here. We're going to put one here. We're going to put one here. Not really. Yeah. It looks ugly. And we're going to put one here. So is aluminum going to have any electrons left?
No.
No, which means I've lost 3, which is why it's going to be +3. Each chlorine is going to gain 1 electron. So what is each chlorine's charge going to be? -1. -1 plus -1 plus -1 is -3. It negates the +3. What this does that I do not do is I don't go to the inside shell. Where's my remote? Crap. I've got so much stuff everywhere. Okay, so what I do differently than what's on here is I do not fall back to an inside shell. I do not draw dots on my metal because they've been stolen. I show where they go. Only the non-metals should have a full octet. There's nothing wrong with doing it this way. I think this way is actually more confusing for you. Aluminum didn't gain any electrons. It gave away its 3 outside and it went inside a level, which has 8. I just don't draw them that way. I really wish I could draw on the screen. I know it's on the PowerPoint. And I think I just totally lost my smart ink too. Oh, there it is. Let me try getting out and getting back. Nope, it hates me. It absolutely hates me. So I would just draw on the smartboard, but that's not going to work. So what I personally do differently is I have my aluminum ion, which is +3. And then depending on where you're going to put them, over here, I have one here. That's how I draw them. It is the exact same thing as over there. I just, I didn't have it 3 in a line on the right. I just know that that's the way that they're going to orient it. No, to me, this is confusing. Showing the inside shell. I don't show the inside shell. I show where they've gone, and I'm going to show the full shell on my anions, my non-metals. Okay, we're going to do some samples, and since I knew the smartboard, here's my clicker, was going to be stupid, I animated them. We're going to do one for magnesium and oxygen. This is why it's so much easier to do this on paper. Magnesium is in group 2. It has 2 valence electrons. When it loses its 2 valence electrons, we already know it's going to be +2. You put your oxidation charges on the top of your periodic table. Oxygen is in group 6. It's going to have 6 valence electrons. It wants 8. It's going to end up gaining 2 electrons, and it will eventually have a -2 charge. So I have, well, that's all on here. I'm going to have magnesium. I'm going to have oxygen. I did them in different colors. I'm sorry if you're colorblind. I found out one of my students in 8th period is, and I've been using red and blue a lot. Like, I'm not picking on the colorblind kids. I know magnesium's going to get 2 dots. They tend to do side, side, top, bottom, and then we double up. Oxygen, we got 1, 2, 3, 4, 5, 6. Would you rather me put the bottom one on the right? I don't care. I have to move my arrows. Where are the magnesium electrons going to go? Are there 2 holes on oxygen? Are there 2 matching pieces from magnesium? So one of them, hold on, I'm going to rewrite it. One of them is going to go into one of the missing holes. The other one is going to go into the other missing hole. Well, if you do it, I had to hide my expos thanks to the student that drew a giant angry penis on my board. All right, so let's say oxygen, So you'd rather me put it like that? Is that what you're saying? What? And let's do that over. I don't care which way you try it. You're showing the motion of the electrons. And I'm gonna do magnesium. I don't have blue ones. So I'm gonna do it in green. Watch green doesn't work. That's sorted. One of these is gonna go here. One of these, I need a new expo. One of them is gonna go there. Does oxygen now have all 8?
Yeah.
So it is going to have what charge? It gains 2. Oxygen is going to be -2. Magnesium is going to be +2. It's actually how you draw an ion. You put it in brackets and you put the charge outside. Your nonmetals, if you do it with the dots, your nonmetals are going to have all 8 dots with negative however many they gain. I don't like putting dots in my metals. It shouldn't have any dots, and it's going to be positive how many it lost. If you're showing the right way we're supposed to do ions, you put the ion in a bracket, the element symbol, and you put its charge on the top right-hand corner still. That's still the same. So if you are doing this with dots, you still have a +2 here, and you'd have a -2 here. This is easier, especially if you're online and you don't want to do dots, unless we specifically ask you to draw the dots. You can put them in brackets. This is understanding where they go. This is easier if you are typing this in online. This means this. The only thing I didn't put up here that I should have was the +2 above the magnesium and the -2 above the oxygen, but I forgot to put it on. I'm going to do one that's, is there something else animated? No. We're going to do something a little bit more difficult. Lithium and phosphorus. Lithium's in group 1. It has 1 valence electron. Symbol is Li. It's going to get 1 dot. It's going to lose its 1 dot. Phosphorus is in group 5. How many dots, how many valence electrons does it get? 5. And it wants to go up to 8, so it's going to gain 3. So how many lithiums are necessary to let it gain 3? 3 of them. This is the much easier section. Covalence, not stephons. I remember struggling with it when I was your age. And so it is going to take 3 lithiums to fill in the 3 missing electrons of phosphorus. So we normally put the one that has fewer in the middle. There's only 1 phosphorus. And then the ones that have more of them that are necessary, we put around the outside. So I'm going to need 3 lithiums, put them in different colors. How many dots did we say that phosphorus was going to get?
5.
I'm so hoping I animated all my dots. I just did this at the end of last period when I was off. Lithium each gets how many dots?
1.
1. Come on, animate. So according to the way I did it, where's the red one going to go? It's going to go right there. And then the green one's going to go to the bottom hole, and the blue one's going to go to the right hole. And phosphorus is going to suck up all 3 of those electrons, and poor lithium is going to be left all by itself. So if I rewrite it with dots, depending on how it's asking, the red one's going to be on the left. Sorry if you're colorblind. That sort of light lime green is going to be on the bottom, and then the blue one's going to be on the right. Phosphorus gained 3 electrons. What is phosphorus's ionic charge? -3, and lithium they each gained, or apologize, they each lost 1, so each lithium has what charge? +1. It's easier, once again, if you are remote, doing this digitally, to do it with brackets. What I should have done, in fact, I'm going to go ahead and do it right now, is I'm going to animate in this. Paste. So the lithium will be +1. Bear with me a second here. I'm going to change this to green. Green. I'll change you to blue. Okay, so if you're doing it with dots, that's what it'll look like. I thought, oh crap. Of course they're not, I keep saying bad words. I'm recording. Oh crap. I said crap.
I am a child.
You were a child? Okay. Okay, so like I said, I forgot to put the -3. Okay, so if you put a -3 here for the phosphorus, then that would make it complete. I like doing it this way better. It's because it's shorter. So really, that's note-wise. Let me freeze this. Note-wise, that's it. Okay, but there is an assignment, which I also printed out because in my opinion, it is a whole bunch easier to do this on paper. But I need to check my online students. Anybody new? No. Okay, I'm going to stop presenting the thingy jiggy.